resource, which is the patient resource. This is the first, and then if you go, so let me just highlight the resource type. Okay, and then let's go to the encounter. There is this encounter, and if you look at the patient that is referenced in this encounter, it should be the subject. The subject should be the same patient that you want. So it's basically the first entry is a patient, and then there are many entries, like for this one is how many? 600 something, 644 like resources that are for that patient. Right? Okay. So now if I go back here, and if I do that query again, that query that counts the number of patients. So now I don't fetch all patients because I have 14 or something. I just fetch the count. So instead of fetching all of the patients, I just say summary count. And these are, if you look at FHIR documentation, you will find all of this. So if I search for FHIR search API, so if you go to the FHIR search page on HL7, like on the FHIR documentation, you will see all of those. So there are this summary. You see that there are different summary fields that you can have. So you can ask for data, you can ask for count. And if I ask for count, it means that you only give me the number. Don't give me anything else. So I now run that query. I go back to my code lab. I copy this. Oh, and there is a total equal accurate. And this is something specific to happy. Because happy, I don't know the internals of happy, but I think it does some caching, and there are some indices to be updated and things like that. Sometimes when you ask for a count, it doesn't give you the exact. So you have to say, give me the accurate total, and then it will be the exact number, which I guess is less efficient. In this case, we don't care, because it's very small amount of data. So yeah, see, we have now 14 patients. Okay? So everybody has 14 patients in their happy server. You can wait maybe a little bit if there's anyone. Is there anyone who is trying to get data to their happy server and they cannot? Is that myself and Patrick can help you make sure that if you get any errors or anything, to unblock. Because after this step, we want to go to actually run the pipeline and get subpart data. Okay, so let's go back to this slide. So we have done this part, we have some data, and now what we want to do is this. So we want to run our pipelines on the data, and first we do the batch pipeline. The batch pipeline basically fetches everything from the FHIR server and all the resource types that we develop, and then convert them to Python. Later on, if we have time, or maybe you can do it on your own, you can add some more resources, and then automatically it captures those new resources after a while. So it has like a periodic check. I don't know, by default it's every hour or something. It checks if there are new resources on your FHIR server, it updates the data. We will get to that. Maybe not doing it today, but we'll just get to talk about it. But let's focus on the bulk part. So let's go back to this. Okay, this is step I just copy paste. It's just creating like a fixed database. Later on, I'll come back to this, right? But for now, just copy paste. So let's do this. So I created, what was it was admin. The admin was the password. So I just created use in my Postgres instance. Now I go to the Docker. Again, okay. Now there are a couple of compose files for our controller. So the controller is basically what we have, like a little UI on top of our pipelines, which is basically to manually run the pipeline or monitor its status and things like that. It's something very basic. So it's basically when we bring up the controller, we can prove that we can run our pipelines. But as you can see, there are like 3 compose files here. And very quickly, I just mentioned what's the difference of these 3. So basically, this first one is just an example if you want to run a cluster, which is how you will set it up. This second one is when you have everything on a single machine, so that's for that. And this third one, it uses the release version of Docker. So it doesn't try to read. The other ones rebuild from your source. So the source that you just downloaded will rebuild first the pipeline code, and then it will run. Okay? So because we want to save time, we just use this release version. And let's also have a quick look at the content of it. Okay, so it has actually 2 pieces to it. One is the controller that I mentioned. It's the pipeline controller, which is basically the output, and this is using this Docker container, Docker image to bring the Docker container. You can skip these. I mean, I guess the most important thing here is that it maps port 8090 to port 8080 on the container. So we can access from the host machine, from the machine that RPM is running. Using port 8090, we can access that control. But there is also another piece to our service, which is the Spark piece. And this Spark brings up just like a single node Spark cluster, such that you can write SQL into the pipeline. So it brings up 2 pieces. One is the pipelines, and the other one is the Spark. So if I go back to my slide just for a second. So you see here that I talk about Parquet tools, and that's basically where our first part, like the pipelines actually end. They generate Parquet files, and they leave it to the developer, to the implementer, to whatever Parquet tools they want to use on top of the base. And there are many tools that understand Parquet. In this example, we are using the Spark to use, it has very good support for Parquet files to query it. So that's why we are using the Spark. Okay, so let's go here. Excuse me, let's bring up the controller. So I just copy paste. And again, I don't write in the detachable because I want to see the logs. Okay, and while we are waiting for this, we can go to our VM and bring up another SSH instance. It's creating the Spark one. Now let's do Docker PS. But they are still not up. So I guess just created it for the volume. Okay, so now they should be created. Yeah, the Spark one is created. The controller is not here. Yeah, this is the controller now. Yeah, and then one of the first things that the controller does is that it creates some tables in the Spark. Because we have a data connection, because we have configured to talk to that Spark instance, it will try to bring up, create some tables and things like that. We can ignore those. Okay, so I have, so if I make it a little bit smaller, it will be nicer. Although I know it's hard to read from the back, but I have basically this container, which is my pipeline controller. So I have this, which is my pipeline controller. I have this Spark instance, and I have my Postgres and Amplify, right? Okay, now that this is up, this is where we need that external IP of the image, okay? So I want to look at we are actually creating like a command line interface for the controller as well, but that's not ready yet. So for now, I just copy this, and I go to port 8090, right? That was the Yeah, and then this is not secure, so we are not using HTTPS. So we are using HTTP. Now you see this is showing the controller UI. So this UI is being served from that VM that I run the controller. So I use the external IP of my VM, the user on, and then I use port 8090 because that's what I do here. So it says that this pipeline controller port 8090 is mapped to 8080 of the actual. Okay? So and then at this point it says that right? It says that there are no data warehouses that have been created, which is not a surprise, right? So the first thing that I can do is to do a run through. And then let's look at the content of that very good H directory. So right now there is nothing in there, right? Now and let's see what's the date now on that machine. The date is December 1st, 12, 43, and 13. So if I now do the run full, so I see the pipeline is starting, and what it is doing now is fetching all the resources from the FHIR server, converting them to Parquet format, and then storing them on the disk. We are already on our session. Okay, so now you see there is
Just a question.
sure, yeah.
I can see in the I can see where you set the connection to the
Right. Yeah, I mentioned it very quickly. So if you look at the content of that Docker compose, so let's go here. So the content of this compose file, so you see here I say map port 8090 to port 8080. So when I bring up this container, so I run this image verification of the container, that controller server runs on port 8080 on that container. So what I'm doing here, I'm saying that map port 8090 of the host to port 8080 of the container. So basically, any request that I make to the host port 8090 goes to that container.
But I still haven't voted because on the server side, on the FHIR side, we set up a table. Which I'll explain to you this configuration. So that this tool can connect to that.
Oh, okay. The thing is that this happy server doesn't need any kind of authentication. So the happy server that they brought up, anybody on the machine can just connect to it. The Postgres database, it's the job of the happy server. The happy server that is talking to, but why am I talking to the database? Oh, you mean when I'm fetching the resources?
It's very private.
Yeah. So the question is that so one thing that I didn't mention, and I guess probably you have used it before. So there are different ways to fetch the data from the FHIR side. One is through the search API. We have a bulk API support as well, and then one of the ways is using the actual database, so directly talking to the database. I didn't get into those details, so those are the details that I see. But I guess the question is that how does the tool know when I run the controller, how does it know the user and password for connecting to the database, correct? Yeah. So that's in here. So if I go to the configuration, so there is a configuration here which is under config. So in my config, so there is an application YAML by config. So if I open this application YAML, so yeah, I am actually using the JDBC mode, so I got it reading from the database. And this is the TP config. So the UAE config is in this file. Let's copy this. People experiments. I think all of them are C. So that's where basically I'm using the database user. Does that answer the question? So the program that I run,
another question.
Sure.
Trying to understand this data.
Okay, sure.
So now this one. So the tool you don't connect to the data.
Which tool?
This FHIR pipelines.
I don't remember.
Because when I run implement, it's not going to have disaster and things like that.
Right.
So, my what are connected to the data. But which I think is not the way. You are using the FHIR endpoints.
No, actually, so there are different ways. So one is to use the FHIR session.
Yes.
But in this case, in this particular setup, we are not using it. We are finding the database. But I mean, and this is because if you look at the application.yaml, so here, so let's open up this page. So you see here, this FHIR fetch mode is app JDBC, which says that you will use JDBC directly top of the database to fetch the FHIR resources. And this is something specifically we have implemented for app. But if you have a generic FHIR set, then you don't use the session. Or
That was my question. Because back at home, I'm seeing how we can implement this part. So we have a happy server. But instead of using the APIs, we connect to the database.
yes,
It's using this method.
And that's what we're doing. Yeah, that's what we are running now.
We're not using the APIs.
We are really. I mean, that's basically using example. If it's just any other generic server, any other server that supports FHIR, then you can't use this. You'll just have to use the FHIR. So the FHIR is a generic for any other server, not necessarily applicable. So if you're really running applicable JDBC server, then you can use the JDBC. You can directly read the JDBC. But if it's not applicable and it's just any other sorry. Yeah. I mean, remember, the FHIR server can be JDBC. No. What's talking about the database management system? I mean, I'm saying that the connection, the server, the FHIR server. Remember, it can be a happy JDBC server or just any other generic server that supports FHIR. An example, OpenMRS, OpenADS, any other server that supports FHIR, but it's not necessarily applicable. Then you need to use the FHIR API. That's the
so it's actually a very good point. Please feel free to ask us. It's much nicer if you have the session as an interactive. Just one note that I guess I forgot to mention one CV, like go to this directory and then run this. So if you have any issues, thanks Patrick for mentioning that. So if you are getting errors with this Docker controls that I run, that's because I went to the Docker directory and ran it and I forgot to save it. And I think there's a step here that is missing here. It should be highlighted as something. But back to this conversation, I really like this conversation because that speaks to. So I guess actually maybe it's a good idea to take a moment and talk about this a little bit. Although I don't have the best slides for talking about this, but I can still use this. So what is this interface? What is this blue arrow? How are we actually fetching data from the FHIRs? So that was this whole conversation that we had on that side of the room was about this, which I didn't get into intentionally because at first I just wanted to go through this quickly. But now that it came up, so we have, there are many different ways to get the resources from your FHIR server. Actually, not many different ways, but at least there are maybe 2-3 ways to do that. The first thing that we implemented, and that's actually when Moses was talking about, when we started with OpenMRS, we used the search API. Now, there is actually a GitHub issue in FHIR. If you go there, and it extensively talk about what are the problems of using the search API. And we can talk more about that if people are interested, but you can also refer to that GitHub issue that this is the problem. The second thing that we implemented was specific to Happy, and that's basically reading from the data. And why is it specific to Happy? Because every FHIR server may decide to implement a data model differently. They are not even obliged to have JSON on their database. But OpenMRS doesn't. OpenMRS has only one data model. They have a FHIR facade which converts that data model. But when we are talking FHIR, we don't care. We don't care what's the number now. Once we go directly to the database, which is what all of us are doing right now, because the default configuration right now is that, then we are tied to a specific implementation. Actually, one of the recent issues that somebody, I think if I remember correctly from Telesoft, actually filed, is that the recent versions of Happy JVM server are pipelines failing. Because they have made some changes to their schema, and we haven't reflected that in our property, right? So that's the problem of not going through this time. Right? The reason that we do that is because it's faster, and it doesn't have the issues that the search. Now, our latest solution, which we think is the solution to the problems that we have had with the search API, also based on the standard, is to use the log API of FHIR. So log API is a more recent API that package operation that FHIR has, and not all FHIR servers support it, but gradually more and more FHIR servers are supporting it. What it does is that you say, give me all of the resources of this type, for example, from this time class. And that's exactly what we want. And that's way more consistent and doesn't have some of the issues that we search it. Right? If we go back, so basically in this case, we are actually using the JDBC mode, which is 5.5. So now let's go back to, so now we have the UI running, we run the one run, and now let's look at the data. Let's go here and see if we have any. Yeah, you see, now we have a directory which has like a name, and then it has a timestamp. And the timestamp is the time that we ran the program, right? So what is the content of this directory? So there is like a timestamp start and end, which says that when I start at the time when it finish. And then for each resource file, I have one directory. And these are the resource files that are pre-configured. So like these, how many are there? These like 20 resource types that I have are the ones that are pre-configured in my application.yaml to fetch it. So let's take a look at that. So if I go to my config, and if I look at my application YAML, then there should be a row which says resources. So you see the resource list here. So it says that fetch patient, encounter, observation, and questionnaire, and so on. So it fetches these 20 resources. And FHIR there are over 100 different resources. Okay? So what is the content of each of those files? So if I go back to the warehouse directory, so let's go to my patient, for example, or let's go to observation, it's probably more interesting. And so you see the contents here are some arguments. Now you can use these Parquet files with any tool that understands Parquet. Okay? Now what I'm going to actually let's just keep that just to run one query. So I remember that I was here, I want to do so I did this, I did the run for chemical this. So I will come back to exploring and visualizing the data. But before going to database, I want to do a command line. So I want to do this, which is the command line environment to query the data. This directly talks to the Spark tree server. So let's see, show tables. So you see, these are the tables that I have. So for each resource, I have a table with that resource type with that in, and also one with timestamp. So as I run more instances of the pipeline, I'll get more timestamps. But let's look at how many patients I have, right? So this is the first time I am writing SQL against my FHIR. So that's why it's important. So I do good old SQL and I say select count star from my patients. And what should I get? If everything is right, what's the number I should get? Remember how many patients we uploaded? 14. Yes, we got it. And now we can do, so now I can say, let's say select any, let's see what happens, right? Patient. Yeah, so see, these are the full data, and I can go and so I can say select a dot even from patient. So these are the given names, right? And now I can do flattening this. You see some people have multiple given names. If I want to, if I'm looking for a specific name, so the results that I'm getting here are arrays. If I want to work on them, it's much easier if I flatten the data and just work with single lines. So we will get to that. At the very end of the roadmap, there is a command line that shows you how to create this interface, but many people don't like the command line. Let's go back to everything. So let's go there. So now I want to query, I'll do the same thing. So it's actually querying through the same endpoint, it's the same Spark endpoint, but we query through this visualization, which is called Metaverse. Right? And I'll try to do it faster. So for running this Metabase, you can use Docker and then fetch the Docker image, or you can run it through just using, downloading the metabase.jar from this address, and then just run it. So do one of these, either do the Docker and then run Metabase, or this step which copies the metabase.jar. Let's do this. I haven't done this actually for every step we added this, so we'll just do that. Let's see if it works. I come out of this on my interface. Metabase container, like the image, Docker image, and then I go and run it. So I am, doesn't matter which directory I am. So let's go to, doesn't matter. Let's go here, and let's run. Let's run. The first time I run this page. I have the interface running. Okay, now what we did here, we also mapped port 4000 of the rows to port 3000, which I guess is the port that Metabase is running. So let's go to this port 4000 and my machine and see what I see. So I copy the external IP of my VM again. I go here and then I look at for 4,000. Hopefully it will blow up. No, it didn't. Okay, so yeah, database. That's the beauty of blocking. So let's get it started. English. Okay. Yeah.
It's great.
Password. You're gonna forget
This
this.
is P1 word. P1. P number 1 word.
Visual C. Okay. All right. Serve service. Correct. Yeah. So I guess here, so let's go back to make sure that you are following instructions. So to create a database connection, I want to connect with Spark SQL. Right? So I go back here, so let's separate this. There should be, yeah, there's a Spark SQL, Spark SQL. Now, for the, yeah, so I need to use port 10,001. And if you are curious when this 10,001 come from, it's from our Docker compose.
That's the, we're running out of time.
Alright.
Right.
Okay, so 10,001. Just call it Spark. Is there any password? Please. Well, it's called this is going to be this one.
That's better.
Yeah. So you're looking for the IP address? Yeah, you run that, it should be 12%. Seven,
Yeah.
but,
So this is the bridge network that we're talking about going to Docker. So that's the activities of that. Okay. Alright. So now database connects to our yeah, it already actually it inspects the tables that we have, create some this one, for example, for observation, which is a query saying that fetching how many observations I have. Now let's do one query and then do one maybe one chart. So step by step here we go to new SQL query. Just copy this, go to Spark, just hit this, run it, you should get the same 14 that I showed you with the command line interface as well. And then you can, yeah, you can do this, and you can create a pie chart. Let's actually quickly do this. Let's do this. So you can go to the visualization and then create pie charts. Yeah. So I know that in my database there are this many female and this many male. It's based on the code. So now you can see that you can quickly create a dash. So this is an open source tool. As you can see, I know only as much as it does. So in the database, I only use it once or twice before. So basically, we just use an open source tool, which is in this case database. And previously, we used to have another. Which one was it?
Superset as well. So it's basically the point is you can really put any, visualization BI tool you use, Microsoft FHIR. So it's just showing it. Open source tools, private tools.
Yeah. So you just basically you are talking to the query engine, which in this case is Spark. So you are just to the JDBC, you send your SQL queries to that engine, and then you get the results back. Now, everything that you do for performance, for example, scalability, deploy your Spark cluster on a clear cluster. So all of those would be hidden from your query interface. Like you have the same interface query or whatever query interface you use, and then your query engine is responsible for okay. Now, make sure that everybody was trying to get to this stage. Managed to do so. I want to talk a little bit about the views, but I want to pause a little bit, make sure that if there are any questions, or if anybody is struggling, there are some terms.
If anyone has any problems, just raise your hand. Questions? Yeah.
Yeah,
Thank you. Can I quickly explain that? So we created a best pipeline. Basically, it says all the resources from this FHIR segment. Thank you. So I was saying, so we started with creating a best pipeline to fetch the resources from the FHIR segment and compare them to IK5. So I'm just wondering where is that conversion headed? Where the conversion headed?
So let me just ensure that I understand the question. So you are saying that so we create this pipeline that converts the data, reads the data from the FHIR server and then converts it to Spark, right? So you are saying where this happens, right? So basically this go back to our so this Docker image that we ran. But this is the log for the pipeline. So basically on the same machine, so everything is happening on that same machine. Right? Because we haven't set it such that when it runs on a cluster. Right? So for example, if I go to my UI here, right? And if I say, do another run incremental or run? Right? So I do like a run, let's do a run incremental just to quickly see that. So it talks to that controller. So see, this is the controller basically response. And if it checks if there are no resources, if it needs to run the pipeline, then it spawn like a pipeline to start the pipeline on that same machine. And that pipeline is responsible to reading the data from the FHIR server. However, if in your setup, you would set it up such that when the pipelines actually run on the cluster, then you wouldn't see it. It's just a controller that's run on that. So because the controller doesn't need to be parallel or distributed, right? It's the pipeline that does the conversion that is doing the heavy lifting, and that needs to be distributed. But in this case, everything happens on that machine. Okay? Any other, yeah, please? Yeah, maybe use the, yeah, you might pass it to me. Yeah. Thank you.
Yeah, thank you so much for this particular session. I really thought it is very beneficial. So in the bilateral project in Syria, of course, we have the integrated supervision basis, where they collect data from facilities across the operational district, and of course they use ODK and link it with a Metabase for visualization. But with this system, they normally pay for hosting. If they pay hosting fee yearly, 5,000 euro, not the rest of it. Well, now, this you've just shown here is like analytic on FHIR with open health system. It's completely free. I just want to know because I want to see how best I could recommend this for the visualization. As we are speaking here, the dashboard is done. We can have access to the data that has been collected, and it's roughly something about 15 to 20,000 data volume that they collect on a yearly basis. So I really want to see how best we can utilize this platform, if it is totally free, or it requires some amount of subscription as when necessary. Thank you.
Yeah, and I'll go through this very quickly. So yeah, everything that we are using here is open source, and by that it's like free, what we call free software, right? So you can take it and deploy it and use it for free. The caveat is that the service that you are paying for, which I don't know exactly where you are getting it from, but usually you are paying for two things. One is the infrastructure on which the service is running, because you need like a computer sitting somewhere to run this. And then the other one is the maintenance, right? So if something goes wrong, like here we don't care, because these VMs will go away for after a few hours, right? But if you have a production system, then you need someone to maintain that service for you, make sure that everything works. If data is not being fetched for whatever reason, debug it, fix those problems. So I think usually the payment for the services, hosted services, so they are probably using like Metabase, like the open source code. They have deployed it in their own cluster, and then they are selling it the service to maintain it. So yeah, I mean, these are considerations, whether you want to pay that amount or maybe you want to pay less but have someone who is actually maintaining it. And then, the benefit of that is that you have access to everything. All the data and everything you have access to. Okay, now let's go spend a little bit of time on, because we are also short, but we have like half an hour or
15 more minutes.
Sorry?
15 more minutes.
15? So let's talk a little bit about querying. So I'll go back to my slides for a second, I guess for a few minutes. And let's try to, so that's where basically we went to the book. So let me talk about this a little bit, and then I leave and actually recommend that you try to do the rest of the quick lab at your home. Even if this expires, when you have like 3 hours you can spend, try this again now that you are registered for this course. Try this again, and then try to do everything to the end, because you get some hands-on experience with doing the quiz for the rest of the. Okay, so our initial implementation, as I mentioned, was on PAR, right? We were doing FHIR resources to PAR. But our vision is that we want the choice of the data warehouse to become an implementation. So I repeat that again. We want the choice of the data warehouse technology that we choose to become an implementation gradually. So what I mean by that is that you don't have to use, for example, Spark. You don't even have to use Arcade if you don't want to use Spark. You don't have those kind of horizontal scalability requirements. Everything can be on a single Postgres instance. We want you to be able to use these things. So basically, to address, to achieve that goal, so as you can see on this image here, you can actually I can use the, now that I am not using multiple hands anymore, I can use a one again. So we want to make the query simple. And then what is the key to making the query simpler? It is to flatten the data. And when we talk about flattening the data, it means that if we have any repeated column, then we try to repeat that row that many times, and then we just put one of the values in each of the rows, right? So it's basically like this example that comes from that observation example. So let's say in the query that I want to make, in many cases, I only need the observation code and observation value. So just take those columns from the observation, flatten the data, and then at the end you just write simple SQL. You don't need to do any of those lateral alter, explode, those kind of things, right? So those kind of flattening is a follow scope for your downstream users, right? So this is a simple example. On left and right are equivalent. The left is against original file data, the right is against flattened data. And like I said, there are reasons why beyond the simplicity, there are also other reasons that we want to work against flatness. Now, this is not just us recognizing that this is a way to query FHIR data with SQL. Many other teams in the FHIR community recognize the same need, and those teams actually came together over a year ago, and they started this actually a year and a half ago, and they started creating a new standard for flattening FHIR data. And that standard, I'm just going through this very quickly. That standard is I think I have it here. Yeah, it's the SQL on FHIR view definition spec. And that's what we call the SQL on FHIR v2. So remember the first one is SQL on FHIR v1, that was the widest view. So this is SQL on FHIR v2. So the SQL on FHIR v2 is basically a JSON object that determines how you do the flattening, which field goes to which column. So if you look at examples, and I think I have one example, although it's not very easy to see. I mean, if you look at the use directory in the GitHub report, there are many examples of that. So if you go to the repository, to FHIR data pipes, there is under Docker again, there is this config and gives. So if you go here, you will see examples of these flat views. So for example, let's pick patient, for example, patient flat view. What it does is that basically it says, I have one column, which is the ID, I have another column, which is this is active or not, I have another column, which is managing organization, reference basically, and so on. So basically each of these is like a FHIR path that you say this FHIR path maps to this column. And how does the flattening work? So you can say instead of that, similar to that explode functions that you will have for each. So you would say this general practitioner, there are multiple of those. Now, for each of them, create a new row and then put one of those here. So put one of these practitioner IDs in that row. So this goes back to that same concept that I showed here. That if you go back to this example that I showed earlier, so you see if I have multiple entries in one of the fields of FHIR, I repeat that row multiple times, and each of the rows I pick one of those values. So that's basically what flattening is. Okay, so I think we need to wrap up soon, so I guess we can't go back to... Maybe I just quickly show the Postgres part, and then we just wrap up. Yeah, let's go. I won't have time to cover the example. So let's go to the Postgres part. We can skip this. Yeah. Okay. Okay, so that view database that I created at one of the stages. That view database is actually used now. How can I do it? Right, we have a structure to connect to the Postgres as well. Go ahead, this one. So I'm doing this step, explore the materialized views in Postgres. So I go back to my database, but again, you can do any kind of query interface. So I create new database connections. Okay, so I want to make a new connection to my my Postgres. So add database. So I think again it's the same. Save address. Yeah, let's save ports. So just following the instructions from the that. Now let's run where is this? Okay, now let's run a new SQL query. So it's our Postgres. So you see, again, it went, once I created that database connection, it went ahead and then just checked all of the tables that I have, and it recognized that I have these tables for all of the patient flat, for example. So let's actually do a query against patient flat. So it has captured some data out of that as well. So where was the SQL query? Okay. So now let's select the star from patient flat. Okay. So what do you think this query should return? Any brave soul who wants to guess what this number would be? It's not an easy question, so let's say it. So what should this minimum, and meaning the minimum for this? Okay, so you need to actually look at the patient flat definition to be able to say this. I just run this without explaining too much on this. So it is a number more than 14, and I tell you what. So first let's run. So it is 90. And let's do actually, I can select star from patient as well. Because now everything is flat, so it's really nice. So the reason is like this one, for example. This one. So the patient ID 4774, right? It has been repeated twice. And if I go back to my new definition, I will see that there is for each one name, I guess if I remember the general definition, which means that that patient, that 4774, they have two names. Because I flattened the data, now I get two rows. Right? So both of these two rows are coming from the same patient. And now it makes it much easier to write queries in this, because I don't need to deal with arrays and this. Okay? Okay. So let me end here, and if there is any comments, questions, I would love to hear. Yeah, please go ahead.
Just for that same example, when it give us now wrong figures, like if I want to say my total count of patients, it is going to add plus that second row. How do we handle that second row?
So you are saying that if I just select count the star, then I got the wrong number of patients, right?
Correct.
So yeah, and then so this, if you just want to count the number of patients, you probably go to the original tables. But how do I fix this problem? So I think it's, so let's do that. So let's explain this. So let's look at this question. So I basically, I don't like, if I usually use the key ID, right? And then you can always, if you want to duplicate, you can always duplicate by items. So if you want, you can do, so let's say you want to run a query, a complex query, and then you want to check it as high variable, right? At the end of your query, you can just pick this patient. Right? So it's basically, that's actually a good point. Usually when I do the flattening, because it's flattening, and I don't get, once you get a resource with multiple rows, I need to account some mistake or group items. But I would say still, those queries are easier and getting it, this. Any other comments, questions? And that's everyone for bearing with me. It was I know that's a lot of content. I really hope that you get to finish the program. And if this session expires, you can try again and let's see. Thanks a lot. And that's not the end of the program.